Hi all, my name is Lawrence Chilrud, and I'll be presenting the work my colleagues and I have been doing on exposure pattern recognition with principal component pursuit. So, why of all the mixtures research questions are we interested in pattern recognition? It's hoped that by identifying exposure patterns, we'll be able to discern sources of exposure, or patterns of behavior within a population that lead to exposure. Now, there are many pattern recognition techniques for mixtures available, including the ones listed in this non-exhaustive infographic. However, many of these methods are imperfect for mixtures problems. Results can be difficult to interpret, outliers can affect solutions, and chemical concentrations could fall below the limit of detection, or LOD. Our solution to this is the Convex Optimization Program Principal Component Pursuit, or PCP, a dimensionality reduction technique from computer vision. PCP decomposes a given data matrix into a low-rank matrix that encodes consistent patterns and a separate sparse matrix that captures unique or outlying events. In this way, outlying values do not affect the patterns identified by PCP and can be utilized as separate information in health models. The photos to the right illustrate this process in the video surveillance realm, with a bustling mall lobby being decomposed into the consistent pattern of the mall itself and the sparse events of people walking by. We've tailored PCP for environmental health problems by engineering 4 adaptations. A non-negativity constraint on the low-rank matrix enhances interpretability, while procedures to accommodate missingness allow PCP flexibility in dealing with varying environmental datasets. Additionally, novel penalties for observations below the limit of detection allow us to leverage LOD information when recovering patterns of exposure. Lastly, a non-convex approach, described in the objective function below, allows us to better model the patterns available in environmental data than the standard convex approach in computer vision-oriented PCP. This is because environmental data often lack the more defined structure found in imaging data. I'll end with an application of PCP to the NHANES dataset. Here, NHANES is comprised of 1,000 US adults with measurements for 21 persistent organic pollutants, many of which fall below the LOD, as you can see in the plot to the right. PCP identified 4 patterns of exposure from the mixture, each with a distinct and interpretable profile. Pattern 1 is driven by lower weight PCBs, Pattern 2 by higher weight PCBs, and Patterns 3 and 4 by furans and dioxins respectively. These informative patterns can subsequently be included in health analyses. The outlying exposure events have no influence on the patterns recovered from the data, and can also be used in health analyses for richer models. Associations between PCP-recovered patterns and health outcomes can then be used to help drive targeted interventions and inform public health policy and regulations. Thank you. If you have any questions, please don't hesitate to reach out. Thanks so much.